The distributive law is actually really straightforward, but when you open it up and have a look at it and it's filled with A's, B's and C's, it can look a little bit confusing. But rest assured, you've probably actually used it before, you just didn't realise what it was called or formalise your thinking. Imagine if I asked you in your head to work out 3 lots of 25. No, let's do 3 lots of 23, say. It's quite normal for people to break that 23 up when they're doing this in their head and thinking, well, if I've got 3 23s, that's the same thing as doing 3 lots of the 20 and 3 lots of the 3. Because if I've got, let me draw it a better way, if the 23 looks like a 20 part and a 3 part, okay, that's still 23, it's made up of 2 bits, then if I've got 3 of them, I'm going to have 3 of the 20s, and I'm going to have 3 of the 3s. Okay, so to write it like this, I've written it like this, breaking the 23 up into 20 and 3, so that we can see that when we work this out, we think, well, what's 3 20s? I know that part, that's 60. And then I need to add on the 3 3s. Now, that's all we're doing with the distributive law. We don't strictly need the brackets there because multiplication gets done before addition, but just putting that in there helps to formalise your thinking. It means taking a number and breaking it up into 2 parts and saying, I'm going to do things differently. Remember in primary school your teacher might have taught you that brackets mean do me first? Well, the traditional way of doing this would be to say, what is 20 plus 3? 23, and then doing 3 of those. But we're actually going a step backward and saying we're not going to do the brackets first. We're going to think outside the square, or outside the brackets, and say if I've got 3 lots of 20 plus 3, I must have 3 lots of the 20, and I must have 3 lots of the 3, and rewriting it like this. Now the reason we do this is because it might give you a way to work out the answer much more simply. Let's have a look at a couple of examples. If I wanted to do 5 lots of 67, I could do it in my head, I could do an algorithm, one of these. But even when we do one of these, aren't we actually breaking it up? We're doing 5 7s, that's 35, and then in the next step, aren't we doing 5 60s? So we're already doing the distributive law when we work it out like this. We're just maybe not realising that we are. So it's a matter of saying I want 5 lots of the 60 plus 7, and that's the same as doing 5 60s, and then adding on my 5 7s. And the reason we like to break that up is 5 60s, that's 300. I can work that out really easily in my head, and I know 5 7s are 35. So it makes it nice and easy to say 300 plus 35, that's 335. Now, many of you will see this and say, I'm okay with just working out 5 lots of 67. I don't need to break it up like this. Why are we doing it? Well, the reason we're learning this, and you can probably see now that in this example here with the A's, B's and C's is exactly what we've done down here. The reason we're learning how to change the form of this and not do the brackets first is because sometimes we can't do the brackets first. Now, this module makes no sense to some children because they look at it and say, there's no point if I have 5 lots of 20 plus 4, you're telling me that I need to change this to 5 lots of 20 plus 5 lots of 4, and you're telling me that's easier to do because this is 100 plus 20, and that's very easy to find. The answer is 120. Some kids say, I don't need to do it that way, Miss Stanton. I can just do 20 plus 4, that's 24, and I can do that in my head that 24 lots of 5 is 120. Well, here's the reason. What if we didn't know how big one of the parts was? This module doesn't take us into algebra, but we need to complete this module before we're given questions like this that do involve algebra. What if we didn't know how big part of the number was? And we said, let it be x, because we're not sure what it is. Now we could actually come up with an expression here that would be really helpful. Because we can't do the brackets first here. We can't add x plus 4, because we're not sure what x is. But what we can do, we can say, if we've got a number made of 2 parts, an x part and a 4 part, and we want 5 lots of that number, we're going to need 5 of the x parts and we're going to need 5 lots of the 4. And so we can actually write that out. If we've got 5 lots of x, whatever it is, that's 5x. That's how we write that. It's 5 lots of x. And if we need to also add on 5 4s, we can come up with an expression like this, which equals exactly the same thing as that, but it looks different. And this is really handy when we're solving equations, to be able to go from one form to another. So that's where this module distributive law is leading you, into being able to use algebra. That's why it's important. Now, in the test questions, they ask you to use pictures to explain the distributive law. Let me show you how you can do that really easily. Let's imagine we've got a question like 4 lots of 10 plus 4. Now, we know that's 4 lots of 14. And they ask you to explain with pictures how you can spread that out into the distributive law. What we're saying is that it's 4 lots of 10 and plus 4 lots of 4. Now, the way to show that super easily in a picture is just to make it all about area. Pretend it's a big paddock that's 4 times 14, because the area of that would be 4 times 14, wouldn't it? The area of a rectangle, you multiply this side by this side. But we could also split the 14 up into a part that's 10 and the leftover part, which is 4. And putting a fence down the middle of this paddock, well, not the middle, but towards the side, is not going to change the area of the entire paddock, is it? We've just divided it up. And we can see now that if the area is the same, if we'd like to work it out in 2 parts, we'll get the same answer. So 4 lots of 10, the area of this part is 40. Let's say these are metres, we better give them some units. And metres squared. And 4 lots of 4 is going to give us 16 metres squared. Now, if we weren't working with metres, the other way to draw this to make it nice would be to take another colour and here break this up into 4 boxes, because that's a really nice way of explaining area. Break this into 10. So now we've got 14 columns here and 4 rows there, and we've got this nice clear division here. And this shows both of these things in the one picture. It shows that 4 lots of 14 is in the picture because we've got 4 here times 14 columns there. But at the same time, it shows that that's equal to 4 lots of 10, because that's just this part, plus 4 lots of 4, which is just this part. So your picture needs to look something like this.